probability that Eric will play golf this weekend is 0.5. The probability that he will play tennis is 0.3. The probability that he will do neither is 0.25. So, it's on the second page, Cody. Just look for it. Find it. Match it. Example 4. So, this looks like a Venn diagram to me. It's pass notes. You have them. They're called mutually exclusive and not mutually exclusive. So, it says the probability that Eric will play golf this weekend is 0.5. The probability that he will play tennis is 0.3. The probability he will do neither is 0.25. So I gave you each one single. I gave you the neither. I need the and. What else do I need in order to figure out the and? What did I tell you need? You need each single, you need a neither, and you need the total. What's the total of a probability? 1, exactly. So we know the total. They don't have to give it to us. We know that if it's a probability of a Venn diagram, it should add up to 1. If it's decimals, it should add up to 100 if it's percents. So what can we do? We can add these all up. We can add up the singles. We can go 0.5 plus 0.3 plus 0.25. So the singles and the neither. And those would be all the probabilities of tickets I put in. So 5, 10, 1. Oh, it's over. It's over 1. It needs to be equal to 1, right? Because probability of the full Venn diagram needs to equal 1. So if I add up each single and the neither, I get over 1. So then what do? I subtract off the total, like we did in set theory, and I get 0.05. And where is that going to go? In the middle. And now we can draw out our Venn diagram and answer some questions. So we draw ourselves our Venn diagram. And I have golf. And I have tennis. And now I have the middle, which is 0.05. And that's the in-between. That's the golf and tennis, right? How can I fill out, what do I go next to on the Venn diagram always? Yeah?
You can go to the snowman and just subtract the sides left and right.
Right, so we can go to, the snowman would be too big, so we have to go to what first? The circles. Because we can't go to the snowman directly right away because we're missing how many pieces in the snowman? 2, and we can only be missing 1 to go to the snowman. But we can go to the singles. So in tennis, it says here, the probability he will play tennis is 0.3. So in this whole tennis circle, I should have 0.3. I already have 0.05. So what do I have to do? Subtract them. 0.3 minus 0.05, and I get 0.25. And that would represent my tennis only, correct? And if it said only, we didn't subtract. Remember we said that? We did that with the test too. Okay, so then the probability that Eric will play golf this weekend is 0.5. So in the golf circle, I should have 0.5. I already have 0.05, so I have to subtract that off. So 0.5 minus 0.05 is 0.45. And then the neither I could have done first or I could do last. Doesn't matter because it's not affected by anything, right? It just goes outside the circles, but inside the square. And now I can answer any questions, but what I should do first before I answer any questions is I should add them all up and see if it equals what? 1. So if I go 0.25 plus 0.25, that's 0.5. 0.45 plus 0.05 is 0.5. And 0.5 plus 0.5 is 1. So I know we're in a good spot, right? So I can answer questions now. It says the probability that we will do at least one of these activities. At least one. So that's 1 or more. In this case, 1 or 2. So it's going to be 75, exactly. How'd you get that quickly? The snowman, the or. It would be the whole snowman. Or what else could I have done? 1 minus
25.
Yeah, that 0.25 and got 0.75, right? Because that would be what was left in the circles. Either way, it's 0.75. Here it says the probability to the nearest hundredth. 100 has how many zeros? 2. So the hundredth is how many decimal places? 2. So that he will play tennis and golf is what we figured out, which is 0.05. You have to start off with a 0 in your numeric response boxes because we don't have a decimal in our first box. Like there's no decimal bubble. If you start off with a decimal here, you literally have no bubble to bubble in on the diploma. So you have to go 0, and then these two boxes have the decimal bubbles. 5. So you have to start off with a 0 if you don't have a number. You can't start off with a decimal. Okay, you guys try this one. All right. We have, in a group of 80 school children, what did I give you? The total. "48 liked cornflakes, 22 children liked both cornflakes and oatmeal, and 20 children liked neither cornflakes nor oatmeal." That sounds like a Venn diagram question to me, right? So, I gave you both, liking cornflakes, liking neither cornflakes or oatmeal, and 80 total. So I know that I'm comparing cornflakes and oatmeal, so it's a 2 circle. Where do I start? In the middle, which is how many? 22. Where else could I go? Yeah, I do like the cornflakes. So 48 would like, if it said 48 like cornflakes only, would I subtract? Only?
No.
No. If it was only, I would just put 48 here, correct? Did it say only? No, it just said 48 like cornflakes. So the whole cornflake circle needs to have 48. 48 minus 22 is? 26. Where could I go next? On the outside, because 20 children likes neither. How can I get this missing piece?
We add them up and then we subtract that from 80.
Yeah.
Make it new.
Right. Because we can use the total when we know everything, but we're missing one thing, right? So if I go 26 plus 22, it's 48, plus 20 is 68, and I need to have 18 total, so this is 12. So I filled in my Venn diagram, and now I can answer any probability question. Because what I've given you before is I always gave you the probabilities, you filled in the Venn diagram, adds to 1, correct? This time I gave you like a good old Venn diagram setup, so you just set it up like a Venn diagram. The catch is that you don't have the percent symbol, right? You don't have the decimals, you have just how much is in each. So when we have the probability, we're going to have to divide by what? What do we always divide by when we have to find probabilities? They didn't give it to us. By the total. Yeah. So I just said the whole word. That's good. All right. The probability is what it's asking me here. So when I see probability, I think number over total. If they give me the probabilities, I can just answer it. So in the previous example, they gave me what the probabilities were, right? So I just pulled it off my Venn diagram and I was done. We agree? Here, have I been given the probabilities at all? No, I've just been giving you a plain old Venn diagram question. So it wants probability to the nearest hundredth that a child selected random from the group liked only oatmeal. So we have to find probability of oatmeal liking. Now, in the previous example, I just wrote an answer, correct? Because in the previous example, this is the probability of this, the probability of this, the probability of this. They gave me probabilities. I have the probabilities. I just write the answer, correct? This example, they gave me Venn diagram. I fill in Venn diagram. Now I need to actually create the probability. Because I never once did, where I wasn't giving probability here. I was just giving the Venn diagram, right? So probability of oatmeal would be number of oatmeal over number total. So how many liked oatmeal only? I guess I should have only. 12. So it's going to be 12 out of 80. And now once it's to the nearest hundredth. Hundredth has how many zeros? 102, so 2 decimal places. So 20 divided by 80? 0.15. And we're done. Why didn't I multiply by 100? And it did not say what? It didn't say percent. If it said probability to nearest whatever percent, I multiply by 100. If it doesn't say percent, I just leave it. Right? Okay. Do you see the difference between the two ways this could be asked? It could be asked where I give you the probabilities. It should add to 1. you give me answers, or I give you a Venn diagram, you fill it out, and then you have to actually conduct the probability yourself. Okay? They can give it either way. Next question. You guys are going to do example 6. And yeah, example 6. Okay, we have a travel agency surveyed 100 people. So they gave us the what? The total. I'm going to write it in highlighter, so enjoy. To determine if they cycle or ski. So it's going to be a 2-circle Venn. They even drew it, which is nice. The results are given below. So we have 68 who cycle, 29 who ski, 17 who do both. So I don't have to figure out the both, which is good, right? So where do I start? Middle, which is 17. Cody, how do I get cycle by only?
You minus 68 by 17.
Yeah, and you get? And then how do I get ski only?
Minus 17 by 29.
Which is 12. How do I get the outside?
You add those up and minus it by the total of 100.
I'm laughing for you, someone with this. You add them up and minus from 100 and you get? 20. Good job. Okay. Now we're going to do what is the, so we answered the Venn diagram. This Venn diagram question could just be a set theory question, right? It could just say how many people are not in, how many people neither ski nor cycle, and you'd have 20 or something like that, right? Or how many people ski only, 12. And you can answer these for set theory very easily. But this one says, what is the probability that a randomly chosen individual from the above group of 100 cycles only? So probability is a fraction, right? So if you have to watch yourself, because people will tell me it's 51, which is not what the answer is, right? 51 people cycle only, that is true, but that's not the probability, right? So the probability of cycling only equals the number of cycle only over what?
Total.
Yeah. So it's going to be 51 out of 100, and you can leave it there because it doesn't say the nearest percent, doesn't say the nearest whole number. Just leave it like that. Okay? Dominic and Laura are playing a board game. To move a turn, Dominic must roll either doubles or a sum of 7. The moment I hear 2 dice being rolled, I'm going to draw an array. You cannot do that, but if you don't do that, there's a good chance you're going to make a mistake. So yes, it takes a few more minutes, but your diploma is 6 hours long and it's set to be done in 2.5, and most people are out in an hour and a half. So I think you can draw an array. I believe in you. You can do it. So we're going to draw ourselves a little outcome array. So we're going to go 1, 2, 3, 4, 5, 6. It's the one-sided dice. 1, 2, 3, 4, 5, 6. And now what I do, personally, if it were me and I were you, and if I didn't have other colors, I would use other colors. But if I don't have other colors, I would highlight this row and this row just so you don't accidentally count them or something. So that you don't count them as an outcome, because they're not. So in this one, I'd have 1, 1, or I'd have 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So it's going to show all the different rolls I can have. And how many rolls can I have if I roll 2 dice? How many different rolls? Do you remember? 36. Because it's 6 times 6. So we have 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So I know it takes a bit of time. However, I won't make mistakes this way. Well, I shouldn't. Can't say that. So here we have Dominic and Laura. So to move a turn, Dominic must roll either doubles or a sum of 7. What's the probability that he will move on this turn? Now we have, he's rolling 2 dice at once. So that's one event happening. And it says the probability he rolls either a double or a sum of 7. So one event and the word or. Do you agree? So I have to decide, are they mutually exclusive or not? Are there any doubles that roll to a sum of 7? There aren't. Bless you. So is it mutually exclusive or not mutually exclusive? Do they overlap? Nope, so it's mutually exclusive. Because this question could literally just be, they could give you this question and ask you if it's mutually exclusive or not mutually exclusive. Bless you. So we know that they're mutually exclusive because there's no overlap. There are no doubles that are sums of 7. Make sure your phones are away if you're out. So, when it's mutually exclusive, we do probability of sum of 7 or doubles equals. Now remember, this is our formula and it's on the very front of the notes. This was the mutually exclusive one with the or. Remember, U is an or. So if it's mutually exclusive, we just take the 2 probabilities and we add them, correct? If there's overlap, we have to take the 2 probabilities, add them, and then subtract off what? The and, because we've counted it twice. We subtracted off 1. So this one's mutually exclusive, so we're just going to do probability of sum of 7 plus the probability of a double. How many sum to 7? 6 out of 36. And I don't want to reduce it because I'm going to have to add fractions, and the only way I can add fractions is if they have common denominators. Do we agree? Now, probability of doubles. Six out of 36. Was this way easier because I actually did an array? Yeah, because you can actually find them way faster. So I know it's time consuming, and I know you're going to not want to do it, but I promise you, way better chance of getting an answer. Now, when we have common denominator, we can add them. We rewrite the denominator and add the top. So it's 12 out of 36, which reduces to a third. So he has a 1 in 3 chance, technically, of rolling a sum of 7 or a double, which makes sense because the sum of 7s and doubles is a third of the numbers, right? 12 out of 36 options. Okay. So this is a summary of those, which we're going to review again tomorrow. But I'm going to give you new notes so you have to put on your masks. Okay. So this is the last lesson. What we've done so far in probabilities, we did odds for odds against probabilities to odds, odds to probabilities. That was one lesson, right? Then we did probabilities with perms and cons. So we did a whole unit on perms and cons. Then we did probability with that. Then yesterday we did mutually exclusive and not mutually exclusive, and we finished it today. So that's where there's overlap or not. And a lot of the time we use Venn diagrams, which we just finished in set 2, right? Then today's our last lesson. It's independent, dependent. So mutually exclusive and not mutually exclusive uses or, right? That's what the or symbol is. So if you look over here, we have the or symbol on our formula sheet. There's the A or B, and that was just the formulas we used, correct? We could only use these formulas if one event was occurring and we had the word or in between, correct? Today's, we're going to use these 2 bottom ones. They're independent and dependent. What symbol is between the A and the B? An and symbol. So that means we have to have 2 events happening and the word and. So for it to be independent or dependent, this here, we're going to write this up here. We need to have the word and and we need at least 2 events. We could have more, but we need at least 2. So, when I just toss 1 dice and I ask you the probability of this or this happening, then that would be mutually exclusive or not. Today, if I toss 2 dice, I'm going to ask you what's the probability of this one being this and this one being this. So, mutually exclusive and not mutually exclusive is 1 event happening. I toss a coin, I toss a dice, I spin a spinner, I do 1 thing, right? Today's independent and dependent, I have to do at least 2. So I have to toss a dice and roll a dice, toss a coin, or I could spin a spinner and roll a coin. I really want to roll coins. I don't know why. I want to toss a coin. Okay. I could take out 1 card and then take out another card. So I have 2 cards in my hands. That's 2 events. With mutually exclusive and not mutually exclusive, I could take out 1 card. What's the probability it's this or this? Okay? So 1 event or 2 events and independent, dependent. Independent events are 2 events that are independent if the knowledge that 1 event has occurred does not affect the probability of the other. So an example would be if I spin a spinner twice. So if I spin the spinner the first time, do I physically take that piece off that it lands on? No. So does the second event depend on what the heck the first one was if I spin a spinner? No, I spin a spinner, it lands on green. I spin a spinner, it could still land on green, right? So those are independent events. So a spinner, a coin would be independent. If I flip a coin, I really want to spin, roll it again. If I flip a coin and I get a head on the coin, if I flip the coin, do I like take the head off the coin and now flip it and only have a chance for tails, or does it remain on that coin? It remains, so it's independent. Rolling a dice is independent. Marbles, taking marbles out of bags can be independent if you have 2 separate bags. So if I have a bag of marbles and I take 1 marble out of that bag and I have another bag of marbles and I take a marble out of that bag, is the second marble dependent on the first one? You're taking them out of totally separate bags? Nope. So, independent events are when literally the first event can't affect the second one, possibly because you're taking them out of 2 separate bags, or because it's on a spinner, a coin, a dice, where you physically can't take that side off. You can't have less outcomes. Okay? So examples of this could be dice, coins, spinner, 2 marbles out of separate bags. Two cards out of separate decks, where it literally can't affect the other one, right? Doesn't matter what I take out, I have a whole new deck to pull the next new card up, right? Dependent events are events whose outcomes are affected by each other. Outcomes are affected by each other. So for example, if 2 cards are drawn from a deck without replacing them, then the second one is dependent on the first. So if I take a card out, and I say, what's the probability of getting a king and a king? If I take a card out and I don't replace it, now I have 51 cards to choose from. It totally affects it. It totally depends on the previous one, right? I've knocked down the amount of cards. If I replace the card, if I take out a card and I replace it, does it affect the next one? I have a whole new deck again, right? Brand new deck again. So, with replacement, it's always independent. Because if you replace it, I don't care what the heck you got in the first one, you replaced it, right? Without replacement, makes it dependent. Okay, so we're going to look at example 1. Bag A contains 9 red marbles and 3 green marbles. Bag B contains 9 black marbles and 6 orange marbles. I have 1 bag, I have 2 bags. Find the probability of selecting 1 green marble from bag A and 1 black marble from bag B. So I have 2 events happening, and I have the word and. So 2 events and the word and, correct? So I have to decide, are they independent events or dependent? Does the second event depend on the first one? So the first one I'm pulling a green marble out of bag A, and the second one I'm pulling a black marble out of bag B. Do these events depend on each other at all? No, it's like you could do them out of order and it wouldn't change. That's how you know if they're independent. If I do the probability of this one, of the bag B first, and then the bag A second, or the bag A first and the bag B second, I'm going to get the same probability. Because the order doesn't matter, correct? Because they're not dependent on each other. So these are independent. So I have to do probability of green marble. Bag A. What do I do when I read the word and? What operation? Multiply. Remember and, multiply, or add? That's why we were adding the mutually exclusive and the not mutually exclusive, because they use the word or, right? These ones use and, so I have to multiply. Green marble out of bag A, black marble out of bag B. So I know probability has to be a fraction. So what's the probability of getting a green marble out of bag A? How many green marbles are there? 3 out of 12. Times 9 black marbles out of 15. So I'm going to get 27 out of 12 times 15. 12 times 12 is 144. I don't want that. I want the fraction. That's 12 times 15. That's 12 times 15. You got there first. 1/8. Does it reduce? It should. You take a 3 out of both. Take a 9 out of both. Three out of 20? So 27 divided by 180, math enter entry. You calculate.
3 out of 20.
27 divided by 180.
12 times 15 is 180.
Yeah.
Sorry? 27 divided by 180? Where am I getting that from?
No.
I'm so
Confused.
I think we're all so. Okay, let's look at this one. 2 seniors, one from each government class, are randomly selected to travel to Washington, D.C. Wes is in a class of 18 students and Maureen is in a class of 20 students. Why is this independent? If they're in separate classes, does it affect what would I take out of one or out of the other? Does it change my total? Nope. Okay, you do this one. Give me the answer. So, we want the probability that both Wes, one event, and Maureen. So we need the probability of Wes and, which means I need to do what, sorry? Multiply. And Maureen. What's the probability of Wes being chosen? 1 out of 18. Maureen? 1 out of 20, which equals? It's a lot of people saying the same number in different random orders. 1 out of 360. Yeah. Does it make sense when you're taking out of 2 separate things how that could work? Okay. Flip over. So, here we have a box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. So how many do we have total? That's always helpful. Did I skip it? I can have it.
Wow.
Oh, so disappointing. I skipped a whole page. Well, I must have hit that arrow quite hard. Okay, good times. All right. So, probability of dependent events. Remember that independent events have no influence on one another. Dependent events do not do have influence on affect the other example events. Wow, I'm gonna try that again. Dependent events do have influence or affect the other events. So independent events often are tossing a coin, rolling a die, spinning a spinner, events with replacement. The sample space remains the same. So your total that you're choosing from remains the same. There's too many phones out. Put them away. So the sample space remains the same because if I replace the card, I still have 52 cards to choose from. Correct? Now, dependent events, events without replacement, the sample space will change. So picking a card and keeping it before picking out another card will affect the sample space that you get to choose from. Yeah. So, we're going to go to dependent events. This one. A card is pulled from a pile that consists of 5 black, 6 purple, 8 yellow, and 1 green. How many is that total?
More than one.
It is more than one. 20 cards. Now this is the key thing to look for. Without replacement, instantly tells me they depend on each other. Because this is a card being pulled from a pile, one pile. Okay? So we're going to take out a card, and then we're going to replace it and take, or not replace it and take out another card. Right? That's what we're doing. It should not be a card. This should be 2 cards. 2 cards are, not is. 2 cards are pulled from a pile.
No, that's no part of it.
No, it needs to be 2. One
One
of,
card is pulled from the pile that consists of that many, and then without replacing the card, another one is pulled.
oh. Kyle.
What can you do without me?
I don't know. Cry. Right? Big tears. Puddle right down here.
Happiness.
I'd be just dehydrated. Yeah, we don't know which way.
Yeah.
Okay. So, we have Y, then B. So we need probability of a yellow and probability of a B. Why did I multiply and not add? That's not a good reason. Why do I multiply and not add? Because I need to have 2 cards, correct? I need it to be a probability of a yellow and black. Everyone needs to pay attention because you won't know to add or to multiply. And remember I told you that on the diploma and on my unit test I have both options. So if you don't remember, you're going to be pooched. Yeah. So we need to multiply because we need this card and this card. Or would mean I have this card. What's the probability it's yellow or black? Right? So if I have 1 card, I would add because it would be yellow or black. If I have 2 cards, I need 1 to be yellow and I need the next one to be black. So how many yellows are there? Out of? Times?
5,
Out of?
19.
19. When we do not replace, it changes our total sample space. It knocks it down 1. So we don't have 20 cards anymore to choose from. We only have 19. Very big difference. And they'll, you know what? I'll tell you what my 4 answers would be on my multiple choice for this. Paying attention. I would do this. I would go 8 over 20 times 5 over 20. I'd go 8, which is wrong. I'd go 8 over 20 times 5 over 19, which is right. I'd go 8 over 20 plus 5 over 19. And I'd go 8 over 20 plus 5 over 20. So if you don't know your stuff, you won't get it right. That's why I say to you guys, you need to know why and understand why. Right? Because every oopsie will be there. So what do we get here?
40 over
40 over 38? 380. So 4 out of 38, or 2 out of?
19.
You guys try the 2, 3, 4, 5, 6, 7, etc. Okay, we're going to do purple and purple. So purple would be 6 out of 20. And then another purple would be 5 out of 19. Yes, we have to take off one of the purples. So what do we get as a reduced fraction?
3 over 38.
Good job. Okay. Green, then black. So green we have 1 out of 20. Black we have 5 out of 19. So we get 5 out of
1/76.
what?
Well, their final fraction is 1/76.
Okay. What, 5 over there, like 1/76. That's good. Okay, I get what you're doing.
Too quick for you.
Yes, that is what the problem was. Okay, green then green. So we have 1 out of 20 times none left out of 19, which equals there's no probability that's going to happen. You can't get a green and a green when you have one green. Black, 5 out of 20. Yellow, 8 out of 19. Green, 1 out of 18. And what do we get?
1/171.
Then we have purple, 6 out of 20 times 5 out of 19 times 4 out of 18, and we get?
1/57.
You could randomly be throwing like crazy answers right now. I should like write them down.
Yeah.
A green, a purple, and a yellow. So 1 out of 20 for a green, 6 out of 19 for a purple, and 8 out of 18 for a yellow. And we get?
2 out of 285.
2 out of 285. Okay, next page. Sure. You guys are going to try this one. Example 4 and example 5. Try. Oh my goodness, I went to scroll and I realized. Example 4 and example 5. So we have a box contains 5 purple marbles, 3 green marbles, 2 orange marbles, which is 10 total. 2 consecutive draws are made from a box without replacement. So without replacement means the second one depends on the first. Now the actual formula for dependent is this. I'm just going to show it to you just in case you're given it. So probability of A and B equals probability of A, and then it has this. Okay? So this is the dependent one. Now what this means is I take the probability of A and I multiply it by the probability of B, and this means given that A happened. That's all this means. It means probability of B given that A occurred. That you're holding A. That you're not putting it back. Okay? That's all that means. So that's why we're taking those values off when we're multiplying. So orange is 2 out of 10 times green, which is 3 out of 9, which is 6 out of 180, or 1 out of 30.
16.
Yeah, it's not 1 out of 180.
Oh, really? Look at it's not. You think this is the problem? The 90 was the problem. I really wanted to times it by 20. Okay. 15. Like you said it, but I'm not listening. Okay. Both marbles are purple. So 5 out of 10 times 4 out of 9, which is 20 out of 90, which is
1/5.
isn't it 2 over 9?
And the first one's 1/18.
I was like, these just cancel off. And you get 2 out of 9.
Isn't the first one 1/18?
The first one you take a 3 out of both, or you could take, 3 out of both, so you get 2, or you could take a 6 out of both. 15, 30, 60, 90. Yeah, it's 15. The first marble is purple, and the second is any color except purple. Purple is 5 out of 10, and then it would be 5 out of 9, which is 25 out of 90, which is? Okay. If you draw 2 cards from a standard deck of 52 cards, you have to just look. If it says with replacement, it just means that it wouldn't affect it, right? Without replacements, when you have to remember to take the number off. So you have to look closely because this question on the test could say it could say without replacement, or it could say with replacement, right? With replacement, it wouldn't affect it at all. So if this was with replacement, I'm just going to show you. If it was with replacement, I'd go a king, which is 4 out of 52, and a jack, which is 4 out of 52. That would be with replacement, correct? But this question didn't say with replacement. It said without. So it's going to be 4 out of 52 times 4 out of 51, which is? What do you get?
4 over 663.
The next one, we have a face card first. Face cards are Jack, King, Queen, then 4 suits. So 3 times 4, which is 12. So we get 12 out of 52. Times aces, which is 4 out of 51. With replacement, that would just be out of 52, right? It wouldn't be out of 51. It's all out of 52. And what do you get for this one?
4 out of 221.
And then we get 2 aces. There are 4 aces, so we do 4 out of 52 times 3 out of 51. And what do we get?
1
1
out of
over
221.
221.
Okay, this is the last thing we're going to learn. That's not true. Okay. Not my you will see.
We'll see next time.
It's like you control the class. You will get those class. That is what we need to do. Okay. So now let's put it all together. This is as tough as probability can get. The odds that Ava will pass math this semester are 4 to 1 in favor. Odds in favor of passing. So where does pass go? Is the 4 pass or the 1 pass? Odds in favor, it comes first, so the 4 is pass, the 1 is not pass, right? And the odds that she will pass English this semester against. So odds passing against. So passing comes second. And then not passing would be first. So when it's in favor, it comes first. When it's against, it comes second. And then its negation or complement comes first. If these events are independent, determine the probability to the nearest hundredth that she will pass math and English. Well, this is what you can do. You can do a tree diagram down here. Or what I do when they do this for me is I write out every probability I can cover. Every probability I can do. So there should be 4, correct? There should be Ava passing math, Ava not passing math, Ava passing English, Ava not passing English, right? Those are the 4 things I can pull from odds, correct? So I'm going to write them out at the top. So I'm going to go probability of passing math, because you need to do this. Probability of passing math is what? Passing is 4 out of 5, because remember we always add to the total. Probability of not passing math is what? 1 out of 5. Probability of passing English. The total is 10. So it's probability of passing English. 9 out of 10. And then the probability she will not pass English. Is how many? 1 out of 10. If I have all 4 probabilities written out, I can answer all of the questions in example 6 in seconds. So, determine the probability to the nearest hundred she will pass math and English. So probability of passing math and English. What am I going to multiply together?
4 to 5 and 9 out of 10.
4 out of 5 times 9 out of 10. To the nearest hundred. Don't turn it into a fraction. Your decimal 7 too? So she has really good probability actually of passing both, which makes sense because 4 out of 5 times 9 out of 10 should be a large, high probability, right? Okay, what is the probability she will pass math but not English? What do I multiply together now?
4 over 5 and 1 over 10.
4 out of 5 and 1 out of 10. So once you have your probabilities written, these questions are quite easy after. So what's 4 out of 5 times 1 out of 10?
4 over 50.
0.08.
Math or English?
4 over 5.
Plus 9 over 10.
Watch this though. 17 out of 10. Does that make sense?
That was
17 out of 10 is more than 100%. Does that make sense? Really?
no.
More than 100% chance she's going to pass both. Pass math or English? No. In passing math or passing English, that means she can either pass math but not pass English, or pass English but not pass math, right? So you can't just do it this way. You will catch yourself trying to. You can't. So she has to pass math and not pass English, or pass English and not pass math. Or what else could she do?
Fail both.
So she has to pass both.
Oh, just
But I can't extend this. Or pass math and pass English, right? She can either pass math, not pass English, or pass English, not pass math, or pass math and pass English. Another way you could do this is probability adds to total, correct? Total is what? How many? What's the total probability? 1 or 100 if it's in percent, right? So if I just went 1 and I subtracted off her failing both, I'd have the same thing. So if I went 1 minus this, nope, failing both, 1/10, 1/5. I would get 1 minus 1 over 150. And so I would get 149 over 150. Whatever that is to the nearest hundred. So if I add those all up or do this, what is it? What's 149 divided by 150?
0.99
So I could take total probability and take off the one case that doesn't work, right?